In this tutorial, we are going to look at some of the flaws in all-of method of completable future. This lecture is not a complete discussion on completable future as such. I have a different video, a 90-minute video on futures and completable futures. If you look at the upper right corner and click a link on that, you will go straight to that video. So if you are unfamiliar with completable future, I would suggest go and look at that video and then come back. You will get a much better understanding of what I am saying. So let's go ahead and start. When you use completable futures, you use a supplier to run using a supply async method of the completable future, and that creates an asynchronous task. So here what we are going to be discussing is a use case which can be split into multiple subtasks and later on join at a common point to do something else. So all of our examples would use a method called task to generate the task, which will then later on be kicked off using the completable futures supply async. So you can see the task method out here. It takes a name, the number of seconds it's going to wait, and then eventually whether it should fail or not. So all the task is simply going to do is going to sleep for a specified number of seconds, and if it fails, then just throw a runtime exception. And more importantly, it is also doing some logging in there. And if you notice, the logging also includes a thread name. And this is important because you will understand how the various lambdas and the code blocks in the completable futures are called by which thread. So with this task and with this logging information, let's go ahead and use the all-of method of completable future. So let's see how to use the all-of method. So here in this example, you see 3 tasks being created: subtask 1, subtask 2, and subtask 3. Subtask 1 is going to run for 3 seconds, subtask 2 is going to run for 5 seconds, and subtask 3 is going to run for 7 seconds. And they are all going to run successfully because the third parameter is false. In the next block of code right over here, you see that we are kicking off 3 different subtasks using the supply async method and passing the supplier to that. What is a supplier? A supplier is simply a functional interface which contains a get method to return the string in this case. You can think about that as just a block of code which is finally going to return a string as the result. Once we create the completable future F1, F2, F3, we are going to use the all-of method to create a combined completable future, which is going to complete when all of these 3 completable futures are completed. Whether successful or not, it's not important. But it will complete only when F1, F2, F3, all 3 of them complete. And with this combined future, we then use a then apply to take any actions when things are successful. And in this case, we are collecting all the results from all of the completable futures and then returning back as a list. And the next method in the pipeline is the join method, which is simply going to wait till the completable future is completed. In case of error, the join method is going to just simply throw an exception. And finally, we print the results which we expect for all of these 3 subtasks. So what do you think will happen when you run this piece of code? Here's what the output console will look like. You see the 3 subtasks which are running on 3 different threads as expected, and they will end on those 3 different threads. And then you get a message called all subtasks are successful. That's inside the code block of the lambda which is passed to the then apply. And then finally you get the results, which is basically subtask 1, 2, 3 as a list. Now the surprising part out here is that why is the all subtasks successful message printed by the common pool worker 3? Now the way to think about this is that when the 3 subtasks were kicked off, the last subtask, which is the subtask 3, completes in 7 seconds. And once that completes, essentially the completable future is completed. And because of that, the next action in the pipeline needs to be run. And that next action is the then apply. And it will be run on common pool worker 3 because that's the last subtask which completed. So what's the problem with this? The problem actually is what happens if one of the subtasks fail. In this case, let's manually fail the subtask 1 by passing an argument of true. We know that if we pass true, that subtask is going to throw an exception after 3 seconds. So what's happening out here is that we have 3 asynchronous subtasks running. One of the subtasks is failing, that is the one with 3 seconds. But the subtask 2 and the subtask 3 are still continuing to run, even though one of them have failed. And what we really want is that if one of the subtasks fail, then the whole method run task happy should fail immediately. But that is not what is happening. If you notice, the join method is not going to return back till all of the 3 tasks are completed, whether successful or not. So even though subtask 1 has failed, it is still waiting for subtask 2 and 3 to complete. And that's a problem because that's a performance problem. So the main problem here is basically that this piece of code is not failing fast. But there is also another minor problem out here. If you notice that the all-of method is actually returning a completable future of void. And in my opinion, this is really an annoyance. It really should have been returning completable future of a collection of a wildcard. That way, we have a handle to all of the results automatically. Because it's void, what I had to do was to do a then apply to actually transform that into a list of strings, which I think should have been automatic. But let's go ahead and correct these 2 problems. What we really should be doing is there should be some way of completing the combined future if any of the completable futures is completed. So here you see when you run the program, you see the subtask 1 is failing, but you also see the end subtask 2 and end subtask 3. That means it is going all the way to end completion, and it should not. And finally throwing an exception. It does throw an exception, but it's too late in the game. So what's the real problem out here? The real problem here is that the combined future, that the comp future variable, completes only if all of the 3 completable futures complete. But that's not what we really want. We want it to complete immediately with a failure if any one of the completable future fails. So let's go ahead and fix that problem. We're going to insert a piece of code just after calling the all-of method. When we get the combined future, what we are going to do, we are going to register a block of code here with exceptionally. And then within that block of code, we are going to complete exceptionally on the combined future. That means we are basically manually making sure that the combined future is completed exceptionally if any one of the completable futures fail. So with this piece of code, if we insert it into our run task, I'm now calling it run task and not run task happy. You see the place where I have inserted that piece of code. You see that the combined future will complete exceptionally if any one of the completable futures complete exceptionally. So what's happening now here? This piece of code is waiting on the join method right over here. But this join method is going to return when any one of the completable futures complete exceptionally. And that's exactly what we want. So if you look at the output of this run task, you will see the subtask 1 has failed, but immediately it throws an exception in the main. There is no end task subtask 2 and end task subtask 3. So that works. But the solution that we have presented is really not very reusable. It's very specific to that problem. Let's make it a little bit more reusable, and I call this the refactoring part 1. So here what I really want is that after kicking off the 3 async tasks, I would like to write a method called failFast, which will take those completable futures and automatically handle everything for me. And then it returns a combined future, which I can just simply use join to get the results. And it'll do the right thing. The join is going to throw an exception immediately if there's an exception on any one of the completable futures. and join will return the results if all three of them are successful. More importantly, it's going to fail very fast, and the programmer does not have to deal with manually creating the list of strings from the completable futures. So let's see how we can write this fail fast. The fail fast implementation actually is pretty straightforward. We have already done this. It's going to take three different parameters, f1, f2, f3, which are the completable futures of the subtasks. Inside the method, we're going to go through each one of them and register the exceptionally method, which internally will complete the futures. That is the combined futures, really, of all of the three. What this is going to do is that this will help in failing our use case very fast. And the second piece of code out here is simply to return the list of string instead of void. This is just a convenient way for the programmers. So definitely this code is much better than before. It is short, concise, and convenient. But it doesn't go far enough. It's not generic enough. Because what happens if the tasks are returning not a string, but some other object? What if we want to kick off 10 different tasks or 15 different tasks? So this method is not generic. So we have to change the implementation of fail fast to be much more generic. And this is surprisingly simple if we use Java generics and var args. So here's the implementation of the fail fast gen. What it's taking is completable future of question mark, which is a wildcard, and a wildcard means any type. And then you have a dot dot dot, which is nothing but var args. What this simply means is that when we call fail fast gen, we can pass any number of parameters of type completable future question mark. And it's going to return a completable future of list of question mark, because we don't really know what the type of that subtask is, which it's going to return. So question mark is appropriate. And the implementation is almost exactly the same, except for wherever there is list of string, we're going to use list of question mark. And how do we call this? We are going to use this method called failFastGen inside the run task refactor 2. Exactly the same piece of code, whereas instead of list of string, we're going to be using list of question mark. It works the same way, but it is generic. But notice here that the tasks that we are using, first one is the supplier of string, and the second one is the supplier of task results. They are two different. And I can have as many number of tasks listed out here and then pass it to the failFastGen, and it'll work fantastic. So I hope you learned a lot about the all-of method out here and how to avoid the pitfalls and the flaws of that method. If you like this video, give a big thumbs up and do not forget to register to my channel for quality content and original content which you're not going to see in other channels.